Hi, welcome to my video on part 1 on solving and graphing linear inequalities. This is the first video in the new unit on more inequalities. And linear inequalities was also done in Algebra 1. Check that out. Okay, let's do some examples. Solve and graph. We have an inequality here which is less than equal to. So I'm going to take this inequality, I'm going to simplify it. So I will obey PEMDAS in that I will work the inside of the brackets first. And inside the brackets I have 2x subtract 3 times. I'll do the multiplication first. Negative 3x plus 6. And inside of this bracket I'll do the multiplication. And if I put a negative 1 here, then I can do both of them, because then it's a multiplication. 2 times x minus 1 is 2x minus 2. Negative 1 times x, negative x. Negative 1 times 2 is negative 2. And we obey PEMDAS and we work the inside of the brackets first. We get a negative x plus 6 less than equal to 7x. And here I get x minus 4. And we'll obey the multiplication, but again this is subtraction, so if I put a 1 here I can treat it as a multiplication. So 4 times negative x, negative 4x. 4 times 6, 24, less than or equal to 7x. Negative 1 times x minus 4 is negative x plus 4. We bring all x's to the left side and we make it negative 7x, and we bring the numbers to the right side. Whoop, I also got a x right here, so I make it a plus x, and I have 4 minus 24, so that gives us negative 10x less than or equal to negative 20. Divide by negative 10, and x is, notice when divided by negative with the inequality becomes greater than, equal to 2. And we want to graph that. All the real numbers greater than 2. 2 is right here and is equal to 2. So it's a solid dot and greater. So there's the graph of it right there. And we're graphing the real numbers, and so that's the solution. So all values of x greater than or equal to 2. And there's the graph with the shading. And we're graphing over the real numbers. Number 2, we have fractions, so we'll find the LCD for 2, 4, and 3. The LCD is 3 times 4 is 12. 2 is a factor of 12. So what I do, I multiply 12 by each fraction, like this. What I'm doing, multiplying both sides by 12, but it's easier when you put the 12 with each of the fractions, and you get the cancellation. 2 into 12 goes 6, 4 into 12 goes 3, 3 into 12 goes 4, and there's no cancellation here, so 6 times x minus 4 is 6x minus 24. We got a negative 3 times 3 is negative 9. Negative 3 times negative x is plus 3x. And 4 times 2x is 8x. 4 times 1 is 4. And 12 times negative 1 is negative 12. We'll simplify this side and we'll add up all the x's. So we have, I said a negative 6, so that's a plus 6 there. I almost made that here. So that adds up to be 17x, negative 24, negative 9 plus 4 is negative 29, less than negative 12. 17x is less than negative 12 plus 29. 17x is less than 17. Divide by 17, x is less than 1. There's no negative, we're not divided by negative, so we don't change the direction of the inequality. And another way to, I'll go back to here, another way to write this down, this starts off at 2, and it's a solid 2 going to infinity. That's in the integral notation. And right here, this is 1, so it's open, 1, and it's going to the left, so it's going to negative infinity, open. And x is less than 1. 1 is not included, so it's a hollow dot. There's 1 there, hollow dot, and less than. So shading, or graphing, all understood to be graphing over real numbers. So that's a 1 there. So it's hollow because it's not equal to, and all the values of x less than that. Okay, let's continue. Now we have another one to do, but this time is a little bit different because we have rational expressions in our denominator. So what happens is that, first of all, I have x plus 1, x plus 4, and this is a quadratic here, and this quadratic is, let's see if it's factorable. X times x is x squared. Factors of 4 to give you a 5, or 4 and 1, plus, product is plus 4, sum is plus 5. So the factorization of this trinomial are these two denominators here. So that means the LCD is x plus 1 times x plus 4. And we also notice that if we let x plus 1 equals 0, x is negative 1. X plus 4 equals 0, x is negative 4. So that means, because they're in the denominators, x cannot be negative 1 and negative 4. Because you put a negative 1 here, you get a 0 denominator. Division by 0 is undefined. Negative 4 right here, in place of x, gives us 0 and is undefined. So x cannot be negative 1 and 4. Keep track of that. Now, the LCD is x plus 1 times x plus 4, so I multiply each fraction by the LCD, x plus 1, x plus 4, x, and I write it down so I won't make an error. And the LCD is x plus 1 times x plus 4. And because I have fractions, I'm multiplying, I'll cancel x plus 1's cancel, so I get an x plus 4 times x minus 2. Subtract, x plus 4 cancel, and I get an x plus 1 times an x plus 1. And the LCDs cancel here and here, so I get it's greater than equal to 5x plus 6. Now I have to obey PEMDAS, and I have to multiply these two here and then these two. So if I do that, I will do, and I'll put it in brackets. So here's what I'm going to do, like this. So I multiply these two by FOIL. X times x is x squared, and this is negative 2x. This is a positive 4x, that's a plus 2x. And 4 times negative 2 is negative 8. And I multiply these two, and I'm like squaring, so I multiply x by x, x squared. 1 times x, 1x. 1 times x, 1x. So x plus x is 2x. 1 times 1 is 1. Now, I'm subtracting, or I put a 1 here. So x squared plus 2x minus 8. If I put a 1 here, and if I put a 1 here, that gives you that trinomial. Negative 1 times those 3 trinomials, it gives times those 3 terms is a negative x squared minus 2x minus 1, greater than or equal to 5x plus 6. And I simplify the left side. X squared, negative x squared cancels. Positive 2, negative 2 cancels. I get a negative 9 greater than or equal to 5x plus 6. Move the 5x to the left. And move the 9 to the right, changing the signs. Negative 5x is greater than or equal to 15. Divide by negative 5. And x, because you're dividing by an inequality, changes to less than. equal to, greater than changes to less than, and we get a negative 3. Now, when we do the number line, we have to watch out for it. We cannot have negative 1. So a negative 1 is right here, so we cannot have the negative 1. We cannot have the negative 4. Negative 1, negative 2, negative 3, negative 4 is here. So we cannot have those two because it makes the denominator 0. And we also have to have the values is x is less than or equal to negative 3. So that's negative 1, negative 2, negative 3, negative 4, negative 5. Starting at I cannot have a negative. It says x is less than or equal to negative 3. So I can have a negative 3 because it says equal to, so it's a solid dot. And we shade to the left, less than. So it's this part, and it's this part. So this is the shading. And another name for this, but what happens, because we have those extraneous roots or the values of x that can't be used, we have to obey. We cannot have the negative 4 or the negative 1. So the solution here is, right here, is we have negative 4 less than, negative 4 is less than x less than or equal to negative 3. And right here we have x is less than negative 4. And that's an OR. So notice we have the values of x between negative 4 and negative 3, but not negative 4. And right here we have less than negative 4, but not negative 4. So this one in the other notation is open, negative 4 going to negative infinity, or, and this is open at negative 4 and closed at negative 3. Again, just a review of the linear inequalities that we've done before, but it's a little bit more complex than we're doing more algebra. So that brings us to the end of the first video on the extra inequalities. And if you like the video, click the like button, click the subscribe button if you're not a subscriber, if you wish, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.